In this recording, we're going to look at transformations of exponential functions. So the first exponential function has 3 to the x as its parent function, but there's a 7 that's its coefficient. So think about what effect putting an a value is on like a quadratic, for example. What does that do to the function? And let's also determine the y-intercept. So take a moment right now to answer questions A and B, and then we'll review that, and you can do C on your own. Okay, so hopefully you thought about where y-intercept, that's going to be where x equals 0. So if we sub in a 0 for x, that gives me 3 to the 0. So that's y equals 7 times 3 to the 0. Well, we know 3 to the 0 is just a 1, right? So that's equal to 7 times 1. So the y-intercept is simply the point 0, 7. Okay, so I can go ahead and plot that point, approximately. And next it says, did the exponential function increase or decrease? Well, what we saw before is when the value is greater than 1, this 3 is greater than 1, it makes the growth increase, right? So we're going to say b is greater than 1, therefore it's going to be an increase, exponential growth. Now it just says create a rough sketch, labeling its y-intercept. We've got its y-intercept in here, and we know it's going to be growing something like this, passes through that point, and grows steeply after that, right? Because it's 7 times what a 3 to the x would be. We don't have any scale on here, that's fine. Okay, I'd like you to work on exercise 6 on your own, and play the recording when you are ready. Okay, so 1/3 to the x. Well, what is adding 4 on the end going to do? It should be a shift. Okay, just like any transformation, adding a value or subtracting a value is a shift vertically, and this is going to be a shift up. So determine the y-intercept algebraically. Go ahead and do that if you haven't done so. Okay, so hopefully you took time to do that. So again, it's when y-intercept, every time you see that, just go ahead and write x equals 0. That's the point along this line where x equals 0. So I've got y equals 1/3. Anything raised to the 0 power, remember, is just a 1. So that means y equals 1 plus 4. So of course y is 5. So we've got the point 0, 5. Right about there. Go ahead and plot that and label it. All right, and then it says create a rough sketch of this function, labeling its y-intercept. Well, what we have now is a shift of all the points. It shifts all the points up, which kind of makes sense. So I have my asymptote, my horizontal asymptote, which I'm going to dot in a line here. That's the horizontal asymptote. It used to be on the x-axis, but now it's all been shifted up 4 units. So now this graph, you have to think about, this is exponential decay, right? Because the value of b is less than 1. So I know it's going to decay like this, coming down, and then hugs the asymptote like that. Okay, so the asymptote was shifted up 4. I should have put my y-intercept label on the other side. That's just going to move everything. I'll leave it. It's fine. All right. Finally, I want to talk about 3 other transformations you might see. So if you have a graphing calculator, you can graph each one of these and see the behavior. If you don't have a graphing calculator, I'm going to show you how to use a thing called Desmos to see the behavior. Or you might already have a sense of what happens when I put a negative in front. Well, same thing as when I put a negative in front of a quadratic, right? It's the same behavior. So if you have your own graphing calculator, graph it. If you don't, you can go to a browser and just Google DESMOS. Get yourself this graphing calculator. So I can do, if I want to do a to the b power, so I want to do negative, I'll just create that, oops, -2, and then I hit this button, to the x. And that shows the graph. And I can slide that down. So A normal 2 to the x would be like this, but negative 2 to the x reflects it over the y-axis. That's what we thought it would do. Assuming the x-axis. Now, if I put the negative up in the exponent, that reflects across the y-axis. And finally, if in the exponent, I'm going to put in parentheses here, and I believe I had x minus 2. All right, so that shifted all my points 2 units to the right. Remember, we used to have a y-intercept here at 1. Now it shifted 2 units to the right. So that's like having a right shift within the function, if you think about your parabola, within the function. Okay, so let's go back in the bottom of your paper. You can just make some notes on that and just list off what the transformations were for each one. Okay, I realize now I didn't do the exact same function. I think you understood. This, being a subtraction, is going to shift it by that amount to the right. Slightly different from the one I graphed, but I think you got the idea. Thanks for watching.